DC motors na. So motors, or the electric motor, is a machine which converts electric energy into mechanical energy. So baliktad siya ni generator. Kung si generator, mechanical energy to electrical. Electric motor is from electrical energy to mechanical. So input natin dito is electrical energy. No? Parang kanina doon sa power flow ng generator from the prime mover to the generator, then generator meron sa mga losses, electrical. Ito baliktad. So principle of operation is same as the generator, but reverse lang. So, electric motor works on the principle that when a current carrying conductor is placed on the magnetic field, is placed on the conductor, mag-react yung flux na magpuproduce dun sa conductor, then magre-repel siya dun sa magnetic field. Kaya siya gumagalaw. So, ang pinaka-term ng voltage induced or kung sa generator voltage induced dito sa motors is back EMF or what we call the counter EMF. So, back EMF may be identified as the induced EMF in the armature of a motor opposite or counter to the impressed voltage driving current in the armature conductors. So, formula, same as ano rin. So, parehas lang yan nung kanina. Kung kanina EG, dito ay EB. So, EB is equals to Z-Pond over 60A. Wherein, yung 1 Weber is equals to 1 times 10 to the 8 newtons. So, EB is the back EMF, P is the number of poles, N is the speed of prime mover in RPM, Z is the number of armature conductors, then yung flux per pole in Weber, yung A is the number of armature current paths, or A is equals to MP when lap winding, 2M when wave winding. So M means the multiplier or the plex of winding, wherein M is equals to 1 for simplex, 2 for duplex, 3 for triplex, and so on. So, for torque. Torque is meant the turning or twisting amount of force. Twisting amount of force about an axis. So, it is measured by the product of the force and the radius at which the force acts. This torque serves as the load on the prime mover. So, kumbaga, siya yung bigat. Kung gaano kabigat yung pag-ikot, yun yung torque. Force. So, armature torque or TA is the torque developed by the armature of a motor at a certain speed. It is also called as developed torque or the gross torque. So, formula for torque armature is 9.55 EB IA over N in Newton meter. Other formulas is 0.159, the number of conductors times the multiplied na number of poles, Weber, times IA, yung pinagkaiba yan, divided by 8. Or, pwede din ito, if foot found kayo or pound foot, that will be 0.1173, ZPO IA over 8. Motor torque is related to the armature current. No? Kung babalikan natin yung formula kanina, ito yun. No? Itong ZPONA ay constant. So we can say that, we can say that the torque is equals to the constant, proportionality constant, multiplied by the flux, multiplied by the armature current. Or tikya. Tikya ba? Kung palitarin mo, yung flux and current, no?
Tikya.
Tikyaw. Pero may mga ano tayo, mga mnemonics na tayo. So for shunt DC motor, as is yan, since yung shunt motor naman has a constant dito. Sa shunt motor kasi, iba ang hindi proportional ang flux sa armature current. Kaya, ito lang siya. TA is equals to K2 IA. For series motor naman, since series siya, yung series winding is series sa armature current. So, yung armature current natin is proportional dun sa proportional siya dun sa flux. Therefore, we can say that TA is equals to K1 IA squared. Parang ito, nag-multiply na lang ito. Then, shaft torque. Shaft torque is the torque available at the shaft which is for doing useful work. So, the shaft torque is equals to 9.55 multiplied by motor output divided by N. The loss torque, ito yung losses natin, is the torque which is due to iron and friction losses. The loss torque is equals to the armature torque minus the shaft torque. So wherein TA is the torque in the armature torque in Newton meter. Shaft torque is the shaft torque, then loss torque, the loss. EB is the back EMF of the motor. IA is the armature current, and N is the armature speed. Okay, number 22. The 22, a 6-pole. So 6-pole, black moon na motor is connected to a 250 volts DC supply. The armature has 500 conductors and resistance of 1 ohm. The flux per pole is 20 milliweber. Calculate the speed and torque developed when the armature current is 40 amperes. So, conductors natin is 500, no? Then, a resistance of 1 ohm. So, RA equals to 1 ohm. The flux per pole is 20 milliweber. Calculate the speed and torque developed. The armature current is 1. So, from the formula, lead or back EMF is equals to Zipon over 68. So, meron tayong back EMF, 250. Conductors, pole, flux, meron. Yung speed yung hinahanap natin, 68. So, A will be MP. So, simplex lang siya, 1 times 4, no? Ay, 1 times 6. So, same lang. Ito, pwede na maka-cancel. So, ano na lang? A flux and over 60. So, back EMF. So, 250 is equals to 500 times 20 times 10 to the negative 3 multiplied by the speed over 60. So, what will be the speed? 900 or 1 to 60? Pero, sabi dito, supply mo is 250 volts. Tapos may resistance kang 1. So kung ang motor mo, may resistance ka dito 1 ohm mo. Ito ay 250 volts. Pag ganyan yan. Motor na kasi siya baliktad. So 250, ang ilang amperes? 40. 40 amps, no? So kunin natin yung EB. EB is equals to 250 volts minus IA RA, no? So 250 volts minus 40 times 1. So EB now is equals to 210. So dapat ito 210. 1 to 1,260 RPM. So, meron tayong choice from C or D. Ngayon, ang gagawin for the torque. What is the formula of torque? 9.55 multiplied by D power power output divided by ano nalagay? Kanina. N. Ha? N. Ay, nako. Power output over the speed. Ano na? Power output, kunin natin, no? 210. 210 volts multiplied by 40 amps equals to 63.66 kilowatts.
Sir, 8,400.
Ano ba?
84 kilowatts.
84
8,400
watts.
Apa, sir.
Okay. Sakto?
Apa, sir.
Okay. Then, yung torque natin, meron tayong power output, meron tayong RPM. So, torque na lang. Torque equals to 9.55 multiplied by 8,400 divided by multiplied by 8,400 divided by 1. Pinakuha namin kanina ng 1.60 RPM. 63.66 Newton meter. Types ng DC motor, no? Baliktad na, no? Flow from the voltage, bibigay si kuryente ng bibigay si voltage ng current papunta sa series field, then pabalik sa motor natin. Magandaan nyo yung generator, yung DC generator natin, pwede siya mag-serve as DC motor, no? So for series field, that is IA equals to IF equals to IN. Power developed by the motor is EB or the back EMF times the kuryente ng armature. Then the voltage or the source voltage is equals to back EMF plus IA times RA plus RS. Number 3 is the compound loop generator. So it consists of a field coil with a combination of series and shunt field. So katulad nung kanina, same lang naman sa generator eh. Yung short shunt and the long shunt compound generator. Then yung short shunt, same figure as kanina sa generator. Reverse lang yung current direction except for the field. No? Same lang yan. Ito naman yung compound wound motor. Long shunt naman ang compound wound motor. So number 23, the shaft torque of a diesel motor driving a 100 volts DC shunt wound generator is 25 Newton meter. Shunt wound. So tulad natin. So yung shunt wound daw, ang torque niya is 25 Newton meter. The armature current of the generator is 16 amps at this value of torque. If the shunt field regulator is adjusted, so kung ito daw in-adjust, so in-adjust tayo so that the flux is reduced by 15%. So yung flux 2 mo is reduced siya ng 15% dun sa flux 1. So what will be the relationship? 100% minus 15 is 85. So 0.85. So yung bagong torque mo increases to 35 Newton. So T1 mo is 25 Newton meter. Then yung T2 naging 35 Newton meter. Determine the armature current at this new value of torque. So this is ratio in proportion. That will be T is equals to K flux IA. Shunt lang naman siya. So torque 2 divided by torque 1 is equals to the ratio of flux 2 divided by flux 1 multiplied by IA 2 over IA 1. So, torque 2 is 35 divided by 25. So, torque 1 kasi is 25. Equal siya sa flux 2. Yung flux 2 natin is 0.85 of flux 1 divided by flux 1. Then, yung current mo sa armature, IA2 over IA1. May IA bang given? IA1 mo is 16 amperes, no? IA2 yung hinahanap natin. So, cancellation na lang ng flux 1, no? Shift solve na lang natin para makuha si IA2. Ano yung value ng IA2 natin?
Yeah.
Tawa ata.
Alright. 26 eh.
26.35. Letter D.
Very hard.
24. May tabi pa. So, 24, a DC motor operates at a 240 volts supply. Okay, the armature resistance is 0.2 ohms. Determine the back EMF when the armature current is 50. So, ayan. So, 240 volts supply natin. Armature resistance, 0.2 ohms. Determine the back EMF when the armature current is 50 amperes. So, easy lang, no? EB is equals to V minus IA RA. V is 240 volts minus 50 amps multiplied by 0.2 ohms. So, back EMF is equals to 230 volts. Letter B. Any questions sa kanila? Torque. Nag-discuss natin yung torque. Yung yung back EMF, then the ratio and proportion relationship of the torque, the flux, and the armature current. Okay, starting of motors. At the initial time of starting of motors, the speed is 0. So, and the counter EMF is also 0. During starting period, full time voltage presses across the armature will produce a relatively large current flowing through it, and it might damage the armature. For this reason, an external resistance must be placed in series with the armature during the starting period to limit the starting current of the motor. It is common practice to permit a maximum value approximately 2 times the full load armature current to be used for starting armature current. So, para maiwasan yung malaking kuryente dun sa ating motors or the armature, kailangan magkaroon ka ng external resistance. So, that will be Rx, or the external starting resistance, is equals to the voltage or the applied voltage divided by the starting current or the starting armature current minus RE. Example 25. A 240 volt shunt motor takes a total current of 30 amps. So, meron lang shunt motor. $240 volts takes a current of 30 amperes. If the field winding resistance is 150 ohms and the armature resistance is 0.4 ohms, determine the back EMF. So, syempre, ito papunta dito, ang armature current pababa, and yung field current ko is pababa niya. So, kunin muna natin yung field current. IF is equals to 240 volts divided by 150 ohms. Then IA is equals to the IL mo is 30 amps minus IF based on KCL. So ano yung sagot dito? IF?
1.6.
1.6. Sakto? So for IA is equals to IL minus IF. 30 amps minus 1.60 amperes. So 30 minus 1.6, 28.4 amps. Then kunin natin si back EMF. Back EMF is equals to V, the voltage minus the armature voltage drop minus IA RA. So 240 volts minus 28.4 amps multiplied by RA natin na 0.4 ohms. What will be your back EMF? 228.64. Letter C. Question? Wala naman. 26. 200 volts DC shunt wound motor has an armature resistance of 0.4. So, same figure as this, no? 26. Shunt lang kasi. volts, armature resistance of 0.4 ohms, and a certain load, at a certain load, has an armature current of 30 amps. So ito daw IA mo is 30 amperes. And runs at, so N1 is 1350 RPM. So lagay ko na dito, no? IA is equals to 30 amperes. Yan. If the load of the shaft of the motor is increased, so kung ang load daw ay tinaasan, so that the armature current increases to, so yung IA2, from 30 amps naging 45 amperes na siya. Determine the speed of the motor assuming flux remains constant. So formulas natin, T is equals to Pk flux IA. Pwede din P is equals to 9.55 P out over N. Kasi sabi may torque, no? Ano pa? E is equals to K flux and speed. Alin dyan yung pwede? Mas mabilis. Econ, no? Econ. Kasi voltage meron. Yung flux meron. Yung N meron. So sa E, kunin mo na rin yung back EMF at condition 1. So at condition 1, so ito yun, may condition 1, I is 30 amps. No? So back EMF 1 is equals to the voltage minus IA RA. So V is 200 volts minus IA natin sa condition 1 is 30 amps multiplied by RA natin na 0.4 ohms. So EB1 is equals to 188 point. Sakto? Sakto ba?
Sakto, sir.
Okay. For EB2, or condition 2, EB2 is equals to V minus IA to RA. So that is 200 volts minus 45 amps multiplied by 0.4 ohms. So what is EB2 or yung second condition back EMF? 182 volts. So meron ka ng kompleto na. Constant naman daw ito, di ba? Ay, wait.
Flux, sir. Parang flux.
Remains constant to. So, E now is directly proportional to N. Or E is equals to K N. So, EB2 divided by EB1 is equals to N2 over N1. EB2 is 182 divided by 188 is equals to N2 divided by 1,350. So what will be N2?
And 106.91.
1306.91 RPM. Or letter D. Tanong? Kanina? 27. For 27 and 28, a series motor. So series motor, no? Meron tayong series field and yung motor. Has an armature resistance of 0.2 ohms and series field resistance of 0.3 ohms. It is connected to a 240 volt supply connected to the 240 volt supply, and at a particular node runs at 20 revolutions per second. So N is 24 RPS when drawing a 15 ampere supply. So determine the back EMF of this load. So parang wala lang yung speed. So N, back EMF is equals to V minus IA multiplied by the sum of the armature resistance and the series field resistance. So that will be 240 volts minus IA of 15 amps multiplied by 0.2 plus 0.2 ohms plus 0.3 ohms. So back EMF is equals to 232.5 volts. Letter D. Hey, 27 pa pala ito. Hindi ako. 27 yung 20. So for 28, calculate the speed of the motor when the load is changed such that the current is increased to 30 amps. Assume this causes a doubling of the flux. So sabi, yung current mo for the second condition is 30 amps, and the flux 2 is increased 2 times ng flux 1. So ganun na, no? E is equals to A flux N equal. Or increase to 30 amps. So kunin muna natin yung yung back EMF no pangalawang condition. That will be V minus IA2 RA plus RS. So 240 volts minus, sabi niya 30 amps multiplied by RA plus RS. 0.2 ohms plus 0.3 ohms. So what will be your second back EMF? $225. Sakto. 0.0 volts. So yun na, meron tayong E, flux, and the speed. So from here, from this equation, so EB2 divided by EB1 is equals to flux 2 over flux 1. Then, N2 over N1. EB2, 225.0 divided by 232.5 is equals to flux 2 is 2 times the flux 1. Then, N2, minigibak N2, wala. So, ito yung nahanap natin. N2 divided by N1 natin na 24 RPS. So, cancel natin yung flux 1. So, what will be your N2? Shift solve na lang.
11.6.
So, that will be 11.6 RPS. Letter A.
Dito.
So, 29 no? 29 no? So, for the horsepower output of a motor, so pag sinabing horsepower class, that is the output. Output power. Horsepower output of a motor is given by HP is equals to 2 pi times the torque times the motor speed divided by K. So, dito, no, horsepower rating of a motor is HP, T is the torque developed by the motor, and N is the motor speed in RPM. So, yung K, i-factor yan, no? Yung 33,000, isasubstitute mo sa K, dapat yung torque mo is in pound-foot or foot pound. Pag 44,760 naman yung isasubstitute mo sa K, dapat yung torque mo ay in Newton meter.
Per second sa tayo, sir. Yung 33,000, sir. Per second, sir, di ba, sir?
1%.
Foot pound per second, sir, sa 1 horsepower.
Wow. For 29, a series motor runs at 800 RPM when the voltage is 400 volts. So, series motor, (800 RPM). When the voltage is 400 volts, no? 400 volts. The armature resistance is 0.4. The series field resistance is 0.2 ohms. So determine the resistance to be conducted in series to reduce its speed to, so ano na yung resistance dito para reduce yung speed niya to from 800 maging 600 RPM. So paano daw natin ma-reduce? With the same current. Okay, we have formula, di ba? E is equals to K P N. Sabi, same current. Ito yung series field eh. So may field current tayo. Yung field current natin or yung Weber natin is proportional to the armature current. Since hindi siya nag-change, so this is also a constant. Ito na lang. So kunin muna natin yung voltage. Voltage muna. Back EMF muna tayo. So EB is equals to, yung first condition wala muna to. Tanggalin muna natin ito. 400 minus 25 amps. So meron pa na siyang 25 amperes na IA. 25 amperes multiplied by 0.2 plus 0.4. This will be your EB1. So 385 volts. Then punta tayo sa E is proportional to N. So E2 over E1 is equals to N2 over N1. So 385 divided by N. So E2 is is equals to, divided by 385 is equals to N2 na 600 divided by 800. So what will be your E2 or EB2? Ilan? 288.75 volts. Then, balik tayo dun sa formula ng back so EB2 is equals to the voltage minus IA multiplied by, ito na yun, yung armature resistance plus the series speed resistance plus, let's say this is Rx. Lagay na lang ako, no? Rx na lang. So, ito, substitute natin, no? 288.75 is equals to 400 volts minus IA na 25 amperes since sabi niya ay same current lang. Then RA of 0.4 ohms plus 0.2 ohms plus Rx. So, tingnan natin si Rx. Ilan yung resistance? 3.85 ohms. And then, letter B. So for number 30, what's the 30? Wala pa. So speed regulation muna. No? Speed regulation, it describes the change in speed of a motor as a load is based upon it. Other conditions remain constant. So it's the change in speed. So the percent speed regulation or the percentage SR, it refers to the change in speed between no load and full load, and is expressed in percent of full load speed. So that is the formula: speed at no load minus speed at full load divided by speed at full load minus 100%. For number 30 and 31, no? 500 volt shunt motor. Volt shunt motor runs at its normal speed at 10 revolutions per. So ito daw 10 RPS, 500 volts. When the armature current is 120 amperes and the armature resistance is 0.2 ohms. Determine the speed when the current is, so IA2, armature current niya is 120 amps, tapos ginawa niya 60 amps. And the resistance of 0.5 ohms. So kapag daw series with the armature, kung may naglagay siya ng resistance. Determine daw the speed. So una, kunin mo natin yung back EMF ng first condition. Yung first condition na back EMF. So EB1 is equals to the volts minus IA RA. Wala pa yung resistance na additional. So 500 volts minus the current of 120 amps multiplied by the resistance of 0.2 ohms. So EB1 is equals to for 76 volts. For second condition naman, EB2 is equals to V minus IA multiplied by RA, the sum of the armature resistance plus the additional resistance, say Rx. So that will be 500 minus IA namin, IA2 is 60 amps multiplied by RA plus Rx. RA natin is 0.2 plus 0.5. So, ilan? 458. Sakto. Then ratio and proportion ulit. E is equals to K O A. Shunt field, the shunt field is constant, no? So 1 na lang yan. Hanap natin is the speed. So, ang N1 natin is, ito yun, no? 10 RPS. So, E2 over E1 is equals to N2 over N1. E2, 458 volts divided by 476 volts is equals to N2 over 10. What will be N2? In RPS. 9.62 RPS. Check natin. Yan, letter B. For 31, determine the speed. 31, determine the speed when the current is 60 amperes and the shunt field is reduced to 80% of its normal value. So, flux 2 is equals to reduced to 80%. So, 80% na flux 1. So, same lang. Ito lang. Gamitin natin, no? So, E2 is equal over E1 is equals to flux 2 over flux 1, then multiplied by N2 over N1. So 458 divided by 476 is equals to, so flux 2 is 0.8, so flux 1 divided by flux 1, then multiplied by N2 over N1. So, N2 natin yung hinahanap, N1 is 10. So, cancel na to, yung flux 1. What will be your N2? $12.02. Yan, letter D. Ano ba? So, the power stages, yung power stages ng motor, nahati din siya sa tatlo, no? Ito yan, no? Motor input. Mag-supply ka ng kuryente. So, meron ka V times I N, or the line current, and the terminal voltage. Siyempre, kapag pumasok kayo sa motor, meron kang copper loss, armature losses, shunt field losses. Then, gagana yung motor dahil sa back EMF. So, yung back EMF mo, that is the driving power in the armature. That is EP times IA. Then, may losses yan. The iron and friction losses. Iron losses are the losses from magnets or magnetizing currents. And hysteresis losses and iron losses. Friction losses yan yung losses due to friction or sa mechanical stage na siya. Then that's the time na lalabas yung motor output po. Ilang torque yung kaya na i-handle. So mechanical efficiency is NM, or the motor output divided by EB times IE. Electrical efficiency, that is the back EMF or the back EMF power, EB times IA divided by the motor input, V times IM. Overall or commercial efficiency is equals to the motor output divided by the motor input. So, ano ba yung mga losses no, sa motor? Copper losses, magnetic losses, and mechanical losses. Condition for maximum efficiency. So, for maximum efficiency, variable loss is equals to the constant loss. Ano yung mga constant loss? Ano yung mga constant loss? Core loss, friction loss, and kung may shunt field siya, pwede rin constant loss ang shunt field. So for the variable losses naman, that is the copper or armature losses. Not all copper losses are variable losses. Yung field, shunt field, itong shunt field sa iba yan. So according to Jacobi's law, the maximum power occurs for a constant suppressed voltage when the generated counter EMF is 1/2 of the impressed voltage. So the maximum power occurs for a constant suppressed voltage when generated counter EMF is 1/2 of the impressed voltage. Sabi niya, EB is equals to IA times RA is equals to V over 2. Sabihin, ito pala, itong IARA, kalahati na nito. So, maximum power developed by a motor is in the formula of V squared over 4RA. Familiar kayo dito sa circuits pa lang.
Yes, circuits. Sa DC circuits.
DC circuits.
DC circuits.
Familiar yan.
Maximum power transfer.
So, for number 32, 320 volts, shunt motor. So, shunt motor dito. Sama na akong drawing ng ito. Takes a total current of 80 amps. So, 320 volts, 80 amps. And runs at 1,000 RPM. So, ito. So, N is equals to 1,000 RPM. If the iron friction and voltage losses is equal to, so P strain is equals to 1.5 watts. The short field resistance is 40 ohms. And the armature resistance is 0.2 ohms. Determine the overall efficiency of the motor. Siyempre, yung efficiency natin is equals to power output over power input, or equals na sa power output over power output plus P losses. So times yan sa 100. Times yan sa 100%. So computin muna natin yung IF. So yung flow ng kuryente, napapasok yung 80 amps, then dito na yan. Yung IA, yung IF. IF is equals to 320 volts divided by 40 ohms. Minsan yan. 8 amperes. So, IA for motor is equals to 80, the load current minus, the line current is minus the field current. It will be 80 amps minus 8 amps. So, the armature current will be 72 amperes. So, computation natin, no? Kunin natin yung power at power loss at the armature. Power loss at the armature is IA squared RA. That will be 72 amperes squared times RA. Natin na 0.2 ohms. 1,000, 30,036 or 1036. Ganyan? 0.8 watts. Then for the field, power at the field, or power loss in the field is 320 volts squared divided by 40 ohms, or V squared over R. Then po, 2, 5, 6, 0. Wala na, no? Kuha na natin. So, power output. Power output is wala. Wala. Pero ba? Hindi na lang. Power input. Ano yung power input? Ha? 320 volts multiplied by the current of 80 amperes. 25,600 watts. So ito, ibayin natin yung formula natin. So efficiency na would be dapat yung power input lang. So P in minus P losses. Baliktad. Times 100%. So P in is 25,600 minus the P losses. Kumpitin natin eh. P loss equals to PA plus PF plus P stray losses. PA is 1,036.8 plus 2,560 plus 1,500. P loss is equals to ilan po? 80.8. Ha? Yeah. 5,096.8. So dito 5,096.8 divided by 25,600 times 100%. So letter B, 80.1%. For 33, a DC motor drives a load at 30 revolutions per second and takes a current of 10 amperes. When the supply voltage is 400 volts, if the total resistance of the motor is 2 ohms and the iron friction and windage losses amount to 300 watts, determine the efficiency of the motor. So series motor 30 RPS takes current 10 amperes. IN equals to IA is equals to 10 amps. Supply voltage 400 volts. If the total resistance is 2 ohms. Sama na yung series field winding 2 ohms. Then P stray or stray losses is equals to 300 watts. Determine efficiency. So, multiply natin yung PA na, no? PA is equals to 10 ampere squared or RA squared RA. 2 ohms. Or copper losses na lang. PC. Total copper losses na yun. So 10 squared, 100 times 2 is 200 watts. Then the power input, P in, is equals to 400 volts multiplied by the armature current, which is 10 amperes. This is 4,000 watts. Kukuha natin yung efficiency, that is P in minus P loss divided by P in. 4,000 minus 200 watts plus yung stray losses na 300 divided by 4,000 times 100%. Ha? 87.5%. Natin. Ba't may ano dito? Naliligaw. Ano? Sleep?
Sleep ba? 8.5 sir yan.
Baka 85.5 na. Ano nga ba yung applications ng DC motor? Lalong mata ko eh. So for shutdown, syempre meron siyang approximately constant speed, adjustable speed, and then kaya nilang is medium torque lang up to 1.5 ng full load torque niya. So applications niya for driving constant speed line shafting. This is used for latches, centrifugal pumps, machine tools, blowers, and fans, and reciprocating pumps. For series motors naman is our variable speed or adjustable speed and high starting torque. This is good for traction work or yung sa mga train stations. Yung LRT, MRT yan. Ano yan, series, ano yan, DC motor. So electric locomotives, rapid transit system, trolley cars, cranes, and hoist conveyors. Yan, series motors yan. Then compound, these are for variable speed, adjustable speed, and pwede siya sa high starting torque. So applications for intermittent high torque loads. So depende sa kailangan yung loads kung short shunt ba siya or magiging long shunt. For shears and punchers, elevators, conveyors, ice machines, heavy planners, rolling machines, printing press, and air compressors. Bakit? Example, elevators, no? Iba ang use niya. Meron siyang pataas, meron siyang pababa. So may motor control siya, kung long shunt siya, kung short shunt siya, kung bababa or pataas. Parang galing lang yun. Kaya variable and adjustable speed. So when reversing a DC motor, reversing the direction of rotation of a DC motor can be done by interchanging the connection of the field or interchanging the connection of the armature terminals. That's two-way. So for last, on full load, a 300 volts, no? 300 volts series motor takes 90 amps. So 300 series motor. Takes 90 amperes. 90 amperes yan. And runs at a speed of 15 revolutions per second. The armature resistance is 0.1 ohms and the series winding is 50 milliohms. Determine the speed when developing full load torque with a 0.2 ohms na diverter in parallel with the field winding. So meron siyang diverter ng 0.2 ohms. So naglagay siya ng diverter, ano daw yung magiging bagong full load torque? Assume the flux is proportional to the field current. So again, i-continue no? E is equals to K times the flux multiplied by the speed. Siyempre, kunin mo natin yung EB1 or back EMF1. Yung for the first condition na walang diverter, that will be for the voltage minus IA multiplied by RA plus RS. So 300 volts minus IA natin na 90 amperes multiplied by RA plus RS. 0.1 plus 50 milliohm is 0.05 ohms. So ilan yung EP1?
186 point.
Ilan?
286 point.
2.5 volts. EB2, so ilagay natin yung diverter, no? That is 300 volts minus 90 amps multiplied by the armature resistance of 0.1 plus the parallel equivalent of the series field winding and the diverter. So paano yun? Formula ng parallel, 0.2 multiplied by 0.5 divided by the sum, 0.2 plus 0.05. EB2 is equals to oh, Raj. Sunod ka na ba? Sige. May EB2. Ano yun?
27 point.
27.
287.
287.4 volts. Okay. Ano pa? So, meron tayong E. Ang hinanap natin yung speed, no? So, yung field naman, sabi, assume that the flux is proportional to the field current. For the first condition, yung flux mo is proportional siya sa IA. No? Which is 9 amps. That is the first condition. For the second condition, may diverter na siya. Proportional siya sa current sa series field or IS. Hanapin natin muna natin yung IS. So IS is equals to, so using current divider principle, that will be 90 amperes multiplied by 0.2 divided by 0.2 plus 0.05. Yan? 72 amps. Okay, punta tayo balik tayo sa econ. So E2 over E1 is equals to the flux 2 over flux 1 and N2 over N1. So E2 over E1, meron tayong E2 na 287.4 divided by 286.5. Paano yung flux? Since proportional to sa IA, ito proportional sa IS, we can substitute 90 and 72. So E2 natin is 72 divided by 90. For N2 naman, wala pa, yun yung ginanap natin, divided by N1. N1 is ilan? 15. So, what is N2? 18.80
80.
RPS. Check natin yung tama. 16. Bakit kaya?
Hindi, kapag pinatap mo sa mga ano ba sa sagot? Sino pwede mo?
Okay, no? Ikaw. Torque. Same torque lang sila. Developing full load torque. Kung same torque lang, let's say IA1 and flux 1 or yung torque 1 is equals to the torque 2. Same lang sila. So IA2, flux 2. So yung first condition, yung flux 1, now, flux 1 natin is proportional to the field current, which is also IA. IA is 90. Tama? Flux 1 is proportional to IA. So, IA1 is equals to 90 and flux 1 is proportional to IA1. So, we can say yung ito is 90, multiply natin sa 90. Equal siya sa IA2. And sabi, the flux is proportional to the field current. So yung field current natin, let's say ito ay IA2. IA2. So, ito palitan natin ng IA2. So, ano yung maging factor? 0.2 divided by 0.2 plus 0.05. So, if 0.2 divided by 0.25 is 0.8. 0.8 IA2. So, ito, multiply natin ng IA flux 2 is directly proportional to 0.8 of IA2. So, lagay ko dito 0.8 of IA2. So, ngayon, ito 90 squared divided by 0.8 is equals to IA2 squared. And square root natin both sides. Ano yung IA2 natin?
100.
Sige, tama yan.
100.6.
100.
0.62.
So, 0.62 amperes. So, ito yung papalit natin dito. Sa EB2. 100.62 amps. So, EB2 is 300 volts minus D, 100.62 amperes times 0.1 plus i-parallel equivalent ng diverter and the shunt field, series field resistance. Or 0.2 times 0.5 divided by 0.25. Ayan po. 285.9. So, palitan natin ito ng 285.9. Tapos dito, iba na to. So, ito, 90 pa rin. Ito, iba na. 0.8 ng, ano yung 0.8 ng IA2? So, flux is directly proportional ng 0.8 ng IA2. Or directly proportional ng 100.62 amps. Ano yung flux? Ano yung possible natin lalagay sa flux 2? Flux 2 is directly proportional to the IA2. Ano yung IA2?
8.8.
Ilan? 0.8 ng IA2. 0.8 ng 100.62. So, 80 something. Ilan, Rajiv? Ba't di ka na yun sa klase ko, no? 80 point. So, balitan natin ito ng 80.5. So, magiging sagot. So, parehas na ba? 16.74 RTs. Okay, copy mo naman. So yun o, minsan nagkakamali tayo pag... No.
Sir, ano po ginawa natin? Nag-recompute ko ba?
Hindi, wala eh. Wala tayong mga sagot.
Nabulabog na eh.
Nabulabog ka ba? Hindi. Open mo na lang ulit.
EB2.
Open mo na lang ulit.
Simula EB2.
Siguro lang sa kamay.
Kasi ang ginawa ko, in-assume ko, 90 pa rin siya eh. Yung pala, may effect pala yung kuryente sa pagbago nung, sa paglagay ng diverter.
Explain niyo, sir.
So, nangyari, diba, una wala to. Kinumpit natin yung back EMF, which is at 90 pa rin. So, ang nakuha natin is 286.5. Then, for the second condition, naglagay siya ng diverter dun sa winding, series field winding. Pero full load torque pa rin. So, tapos nag-assume siya yung flux proportional to the field current. Kaya hindi natin alam, meron palang relationship yung sa torque and the armature current and field winding. Ano yun?
So, di ko lang na-gets yung ano, bakit po dun sa 90 times 90,
Yung ngayon din, sir, yung 20 times 90 po.
di ko na-gets yung equivalence.
Kaya, Di ba meron tayong to?
Yes, sir.
Ratio and proportion, no? So we assume torque. The full load torque siya, so equal siya sa torque. Then, meron ko formula na IA field equals to IA and field. So this is 1, 2. Yung tinatanong mo is, bakit 90 to parehas?
Yes, sir.
Proportionality lang naman siya. Kumbaga, ito, pwede kong i-as this as IA1 divided by IA2 is equals to flux 2 over flux 1.
Yes, sir.
So, pag sinabi niyang assume flux is proportional to the field current, proportion siya. Proportion in the same way na kung ano yung nag-change dun sa field current,
Ganun din yung
babago din si flux. Yun yung sinasabi niya doon ha. Ito kasi yung field natin eh. Kung ano yung nagbabago dito, kung ano man yung magbago dito sa field current, yun yung magbabago sa flux. So, sa unang condition, bakit 90? Kasi wala pa to. Series siya. So, 90 siya. 90 amperes yung dumadali sa series field winding. So, yung field current mo rin, proportional siya sa change nung 90 amperes. Proportional siya doon sa 90 amperes na yun. So, whatever change doon sa 90 amperes, proportional siya. Then, yung second condition naman, sabi, yung flux 2 or yung, okay, flux 2 is proportional to the field current pa rin. Ito pa rin yun. Naglagay ka ng diverter. So, you need to compute yung bagong field current. Hindi natin alam, kanina, hindi natin alam na ito palang current natin, magbabago pala yung main current. Dahil sa condition ng torque. Ano yun?
Sir, hindi ko tatanong, can you recompute everything?
Sige. Okay.
Okay lang po.
Okay lang.
Bago na start. Isa
Lahat, number 1.
Ilan sa sa problem na.
Okay lang naman sa akin, number 1. Basta may pizza.
Objective na naman yung kasi.
Sige.
Thank you po, sir.
Okay lang. Ito na kasi nang-late na ng stage.
Sure.
Lumapit kayo para okay.
Kasi may late tayo man minsan kasi may late tayo pagsiksikan yung sarili natin.
Huwag ganun.
Lumapit ka ba?
Yan, lumapit ka pa, pinagsisikan mo talaga. Joke lang. Okay, series motor, no? Redraw natin.
Nag-collapse lahat eh.
Collapse lahat. So, 300 volts, 90 amperes. So, si IA1, 90 amps. Armature resistance, 0.1 and 50 milliohms. No? Okay, ito muna tayo. Compute natin si back EMF. EV. It's equals to 300 volts or V minus IA RA.
Sir, review niya na.
O, EV1. Sige. EV1. EV1 equals to V minus IA1 RA1. So, 300 volts minus IA1 of 90 amperes multiplied by 0.1. Since meron series field, so gawin tayo ng RS. 0.1 plus
15 micro. Ay, milli.
0.05 or 50 milliohms. So, ano nakuha natin dyan?
286.57.
286.5 volts. Ayan, ayan. So, sabi niya, naglagay siya ng diverter.
Papasok na yung
Withdraw natin.
Yun yung diverter, sir.
Lagay natin yung diverter. Para hindi kayo nagilito. Withdraw natin. Naglagay ako ng diverter. Para daw hindi uminit yung windings. Sabi nila. So ito, nagbago na. IA2. This is 0.05. Ito ay 0.2. 0.1. So sabi, nagbago na yun. Dahil sa ikon, Dahil sa econ, syempre, yung IA2 mo, nahati sa dalawa. Yung kuryente dito at kuryente dito sa field or sa series field, IS. Syempre, kung ito ay 90 ulit, bababa siya. Bababa na to. Hindi bumaba yung kung field mo bumaba, that means yung voltage mo dito sa EB, bababa din. And, dahil na bumaba lahat, magbabago din si IA2. Since series field ka, the field is directly proportional to IA. So, ganyan yan. Bumaba. So, magbabago daw talaga. So, from there, hindi tayo makakuha ng sagot dito, no? Kukuha tayo ng sagot sa torque. T is equals to particle, no? So, assuming full load torque pa rin siya, yung kaninang condition naman is full load torque din. So, T2 is equals to, or T1 is equals to T2. So, T1, IA1, and flux 1 is equals to IA2, and
Ano yung 1996?
flux 2. So, sabi sa IA1 is 90 amps. Si flux 1 naman, sabi, assume the flux is proportional to the field current. From the first condition, ang dumadali na flux ay na kuryente sa series field is 90. Eh, field yan eh. The meaning of field. Mali tuloy. Yung the meaning of field itself, that means it's connected to the magnetism. Okay? Yun. Yung flux na yun. So, since dito ko nalalagay, no? Flux 1 is directly proportional to IA. We can say that we can say equal din sa 90 amps. So, substitute ko dito sa 90 amps. IA2, ito yung nahanap natin na bagong kuryente. Then, yung flux 2, sabi, flux 2 is directly proportional to to the field current. Field current. So, field current dito. So, IS. So, IS. So, kunin natin si IS. So, IS now is equals to IA2 multiplied by current divider principle, no?
Yes, sir.
Multiplied dun sa current divider principle. Since ito yung kinukuha natin current, hindi ito may kukunin natin current, ang factor is 0.2 divided by 0.2 plus 0.05. So, ano na? IS is equals to 0.8 ng IA2. So, ito, substitute natin dito. So, therefore, ito, 0.8 ng IA2. Balik tayo dito. Dito na, 90 squared is equals to 0.8 ng, or, okay na. 90 squared divided by 0.8 is equals to IA2 squared. So, square root natin both sides. Makuha natin si IA2.
Teka lang.
IA2 is equals to 100.62. Tama ba? 100.62? 62 amps. So, kunin na natin yung back EMF no condition. Ito. So, EB is equals to, or EB2 is equals to P minus IA multiplied by RA plus yung parallel equivalent ng RSN. So, RS multiplied by the diverter or RX divided by RS plus RX. So, substitute 300 minus 100.62 amps. Then, 0.1 plus RS na 0.05 and 0.2 then 0.05 plus 0.2. So, EB2 is equals to 285.9. Sakto.
Yes, sir.
Tapos balik tayo doon sa Econ. E is equals to K flux N. So E2 over E1 is equals to flux 2 over flux 1 and N2 over N1. So 285.9 divided by 285 divided by 286.5 is equals to flux 2. May flux 2 na ba? Wala.
Sa topics na namin, sir.
So sabi natin, flux 2 is directly proportional to IS. So IS natin is equals to 0.8 ng 100.62 amps. So yun yung 80 point. Ha? 80 point?
Something.
80 point something.
40.5, sir.
0.5. Okay. So yun yung lalagay natin sa proportionality. So 80.5 amps divided by flux 1 is proportional to 90 amps. N2 yung hinahanap. Ayun, 16. So N2 divided by N1 natin na 15. So N now is equals to 16.74 RPS. Yan, basta mas maayos.
Alright. 1 point.
1 point siya, bahaba ko sinagot.
Sir,
Ano yun?
parang nag-iba. Kanina 72 siya eh. 72 over 80.5. Hindi siya...
Ngayon yung kanina yung magulo. Ay, magulo ko yun.
Paulit na ulit, sir.
Robust na.
Eh, sinunod lang natin yung kanina. Ay, yung ano, yung tama. Yung sa proportionality na.
Basta na hindi ngayon,
So,
sir.
dito lang naman nagkagulo eh. Sa pagkuha ng flux tsaka sa ano. EB ko.
Tatandaan ko lang.
Ano iba dyan yung ano? Yung ano, yung formula ng P-stray. P-stray at ano. Wait, Anyway, dito tayo sa objectives. So which of the following statement false is false for a series wound DC motor? A. Speed increases with increase of resistance in the armature circuit. B. The speed increases as the flux decreases.
C.
C. The speed can be controlled by a diverter. Or D. Speed can be controlled by a shunt field regulator.
Mahaba.
Ano? A,
Mahaba,
B,
sir.
C, D.
Mahaba.
A.
Mahaba, sir.
C. Hindi dapat B. B lang false. Perfect.
B nga.
So the speed can be controlled by a shunt field regulator.
Series na yan.
Pulse 9.
Bakit? Hindi mo makakontrol ng shunt field. Kasi nakaparallel na. Oo. 36. Which of the following statement is false? A series wound motor has a large starting torque. True yan. Large starting torque. A shunt wound rotor must be permanently connected to its load. Permanent naman.
C.
Speed of a series wound motor drops considerably when load is applied. For letter D, a shunt wound motor is essentially a constant speed machine. So answer is D.
Ako tinaman ko wala.
37, the speed of a DC motor may be increased by increasing the armature current, decreasing the field current, decreasing the applied voltage, or D, increasing the field current.
Increasing the field current.
So the answer is decreasing the Field current. Bakit? Ito. Nangyari dito. Dinigris mo to, syempre, lalaki yung armature current. So, mas malaki yung back EMF, mas malaki yung speed. 38. The effect of inserting a resistance in series with the field winding of a shunt motor is to increasing the magnetic field, increasing the speed of the motor, decrease the armature current, or D, reduce the speed of the motor.
That's the speed of the D.
So the answer is D, increase the speed of the motor.
Akala ko reduce.
Yung tanong kasi, parang
Uh,
Series.
39. With a DC motor, the starter resistor limits the armature current to a safe starting value. C. Controls the speed of the machine. Letter C. Prevents the field current flowing to damaging the armature. And D. Limit the field current to a safe starting value.
C.
So the answer is A. Limits the armature current to a safe starting value. Dahil winding ko yun eh. So pag masyadong mataas yung kuryente doon, masusunod yung windings. 40. If the two leads of a DC series motor are reversed, which of the following event will happen? So the answer is, it runs in the same direction as before. Kasi ano naman yung DC na yun. Kasi if two leads of a DC motor are reversed, which of the following? Ano ba yung condition in reversing? Babalikan mo yung polarity ng field or yung armature polarity. Okay? 41. The rotating part of a DC motor is known as
Armature.
okay, armature.
Rotor. Anong kawala?
Yung pole. Ay, ko yung pole. Stator? Hindi ko itong stator? Hindi naman. Kasi ang carbon brush yung dito. Yung carbon brush.
Yan, carbon brush yung dito. Mag-uubos na.
Baba. Wala nakataw flux. Pag pinaigot mo yung carbon brush. Okay, 42. The counter EMF of a DC motor is 0 when?
Armature is not turning.
When the armature is not turned.
Nagkakat na flux.
Yun na nga yung magkakat ng flux, yung papapaigot. Yun na naman yung magnet yung paigot. Mas malaking gastos yun.
Letter C.
43. The speed of the DC motor is directly proportional to
Bakit?
back EMF. From the formula, E is proportional to the flux and the
Wala naman.
speed. Okay, equal. 44. Which of the following statement is false? A. A DC motor converts electrical energy to mechanical energy. True. True to. Efficiency of the DC motor is the ratio of input power to output power. False. So a DC motor converts, a DC generator converts mechanical power to electrical power. True. The efficiency of a DC motor is the ratio of output power to input power. True. So, sagutan is
B.
45. If the following statement is true. False.
Mahaba.
So, a commutator is necessary as part of a DC motor to keep the armature rotating in same direction. A commutator is necessary as part of a DC generator to produce unidirectional voltage as terminal of the generator. B is true, no? The field winding of a DC machine is housed is that on the armature. And the brushes of a DC machine are usually made of carbon and do not rotate in the armature. Yung D and B ay true. So, ano sagot nyo?
A.
A or C?
A.
C.
C.
Ano yung pinaka-A?
Makuha na lang ako ng ano.
Hindi ba? Baka papel.
So, pasulat ko na yung email niyo. Sa akin. May sasend ako sa inyo.
Alright.